to welcome our session chair, Alexander Naumchev, and co-chair, Mansour Haziev. So, Alexander, hello. Wait, we can't hear you now. Let's check it now.
Can you hear me now?
Yes, now it's perfect.
Okay, thank you. So our first speaker is going to be Apostolos Kritikas, and he will tell us about an empirical investigation of sentiment analysis of the bug tracking process in LibreOffice open source software. Please, Apostolos, you're welcome to start.
Hello, everyone. First of all, can you hear me?
Yes, very well.
First of all, I'd like to thank you for having me in the Open Source Systems 2020 conference. Thank you for an extraordinary effort to make this happen remotely, and congratulations for the organization. It's been great so far. I'm very happy to be part of it, and congratulations to everyone volunteered and worked for this. Should I share my screen now? Is it okay?
Yes.
Okay. So our work has a title, an empirical investigation of sentiment analysis of the bug tracking process in LibreOffice open source system. And at this point, I'd like to take the chance and thank the two co-authors of the scientific work, which is Theodoros Venetis and Professor Stanelos, also my supervisor for my PhD work in the university. I will try and be brief, although we have lots of things to in this work, but due to brevity of time, I'd try and be brief. So a couple of things about the work. We tried to investigate sentiment analysis of the backtracking process of open source software, and why do this in the open source software realm? Because, of course, there are lots of data, and its main strength is that it continuously evolves, and it's maintained by the community. So we have a hugely dynamic system with continuously new information going in the maintenance field through the backtracking efforts of the community and the people that are working the software itself. Why LibreOffice open source software? It has a very rich code base. I'll give some numbers in a while. And it's a software that has a tremendous evolution through its history. I mean, it started as OpenOffice, and then there was a fork and a huge change in its community. It took many forms, and now it's still alive. It's still a very vibrant project, and we think that there's a lot of information there to study and do scientific work with that. Why sentiment analysis? Because we believe that there is a huge information in the community of an open source project that we have the possibility to investigate, and valuable emotional information may come from investigating the data coming from the bug reporting of the end users and the contributors of the projects. Our case study plan, as I said, LibreOffice has a rich code base. At the time of writing, we had 86,472 commits, nearly 2,000 contributors, more than 9.5 million lines of code, and a very active community, as I believe most of the audience already knows if they're using the LibreOffice project as I do. We studied 16 major releases, and I'm giving them in the parentheses, and from them, we gathered 740 bugs with 6,960 comments. In those, we have bug-related data, comment-related data, And we're also tracking the order of the comments, which is important for us in order to be able to know how the discussion went, who is answering to who in a thread that started from a bug reported. Let me here clarify that when we say bugs to our scientific works, we refer to threaded conversations that started from the initial bug reported. Due to brevity of time, I will not discuss one by one the parts of our data set, but I encourage the audience in the end to do questions on that part if they feel that they need clarifications. So moving on to our statistical analysis, we first needed to see the distribution of comments to have an idea on how the comments are spread in the different versions that we tried to study, and you can see this in the figure figure 1. We then moved on by producing some box plots to see if we have outliers and if we need to perform a data reduction to our data set. But in the end, we avoided doing so because the variations of the volume of the comments in most of the cases has been explained. For example, if you see some variations in the number of comments between the version 4 and 3. This happened because that's the point where LibreOffice was born from OpenOffice, and there was huge refactoring of the code, therefore huge activity from the community in reporting bugs in the changes of the code. So we didn't do a dataset reduction, and we moved on in producing the descriptive statistics of our variables, which is the ones that are depicting in table 1. And then, because as we see, there is a skewness near to 1 in some of the variables, we needed to perform a normality test, and we chose Shapiro-Wilks test in order to be able to see which of them are following the normal distribution and which not, because we were expecting that some wouldn't. Finally, as we see in table 4, we tried to find the correlation between the positive, neutral, and negative comments of the two sentiment analyzers that I will say a couple of things now. If the data between them are strongly correlated, in order to be able to know that our data have a significant to be collectively studied. Now, a question that we had, a comment that we had from the reviewers was why we choose to work with two different sentiment analyzers, and I'd like to take a minute and discuss that. The answer is because we needed some different types of data that the two tools were giving us. And as you can see in this slide, the Vader analyzer, apart from the basic sentiment score of a text, also gives us some variables that we want to discuss in this work, like the irony in the comment, or objectivity and subjectivity in the comments and the bugs reported. I will get to this in the discussion part. First of all, our initial goal for this project is to try and investigate whether it is useful and meaningful to discuss sentiment analysis on bug reports. And this question comes from an intuitively observation that the backtracking process in an open source software mainly has technical text in the comments. So one might argue that why one wants to investigate sentiment in these kinds of text. So what we came across to our work is that, first of all, as you can see in table 2, in all of the versions that we studied, there is a mean significance, a mean confidence in the sentiment analysis more than 90%, which is over 90%, which shows us, which indicates that the tool is confident that it observed rightly the sentiment of its comment that we studied. Also, in table 4, as we can see, although we use two different sentiment analyzers, as I said, there is a strong correlation in our analysis. So between the two tools, therefore, we have a clue here that the two different kinds of analyses are sort of finding the same results in the analyzed data set. Our investigation continued with investigating other things that we can find in comments regarding the sentiment, like the irony aspect and the objectivity subjectivity I said. And here there were some good observations that were done from our results. First of all, we found little comments and bug reports that were tagged as ironic. And this is something we intuitively expected because, as I said, we mostly expect to find technical information in the backtracks, and mainly comments of people that are trying to report something that doesn't work. And usually they're not ironic doing that. However, there were some cases that were flagged as ironic tags in the discussion that followed a bug reporting. However, even in those cases, some of them were false positives, as the one I'm showing in this slide, where you can see in the parentheses where it was flagged as ironic only because there was a part of it in capital letters, which the analyzer thought it's someone that is frustrated and tries to express this frustration via text, which is something very common, for example, in social media, but not in the backtracking system. This in this case, the person doing the comment was trying to stress that this is a comment that is persisting, and nobody has done something for that in a long time. And I'm just stressing that it needs to be taken care of. As far as the objectivity is concerned, we don't have a strong finding on whether it's low on high or high in open source software, or in the specific open source software LibreOffice that we were investigating. But we also found that there are several cases that are misunderstood by the tools, like the one I am stressing here, for example, which, although it's not a subjective, it's not a subjective comment, it is mistaken as such because at some point the author are saying we are changing, which the tool implies that it is their own decision out of an opinion they have, and not because they know what they want to do. So as far as the threat stability are concerned, we have mainly the problem that we have technical text and there is jargon related to that, specific terms. And we're also having personal comments by users that are using the software and they want to express their feeling and their experience. So sometimes there are personal phrasing and style of wording that are confusing the analyzers and are making the analysis a bit difficult. Moreover, there are cases of subjectivity from specific groups of users that are trying to make a personal opinion pass during a specific matter in a widely used software, or as is the LibreOffice open source software. And finally, a thing which we intend to make use of in our future research, due to space limitation to the conference publication, we decided to group our research in the specific versions we studied, but the truth is that the data we have collected are more vast and can and so this investigation can be extended and looked more thoroughly in some aspects of the ones that we're investigating. So to conclude, as future work, we plan to repeat our experiment in other programming languages and styles of coding, like Java, PHP, so forth. And we intend to also include metrics and study it in parallel with the sentiment analysis. For example, in order to be able to draw some conclusions for the structural properties of the source code. Also, we had some proposals from the reviewers to also try and investigate other sentiment analyzers and see how the data are appearing in their analysis. And this is also something that we are thinking we're going to try in our future work. At this point, I'd like to thank you very much for hearing me. And of course, whatever questions you have, I'll be very glad to hear and reply. Thank you very much.
Thank you so much, Apostolos. I think we're unfortunately out of time for questions, but because we're in Zoom, we can continue the question and answer session in the chat. So I'm going to ask a question from my side shortly. So thank you so much, Apostolos. And I'm now passing the turn to Nikolai Rutyunyan with his talk called Challenges of Tracking and Documenting Open Source Dependencies in Products, a Case Study. Please.
Hello. Hello. Yeah. My name is Andreas Bauer, and I'm here the main author of the paper, and I will present.
Okay. Sorry, because I thought.
Yeah, no problem.
Andreas Bauer, please.
As I said, my name is Andreas Bauer, and I'm the main author